Hello and welcome to the vectors unit. So the first thing we're going to do here is do a little bit of a review that we did way back in chapter 4 it might have been. So we're just going to go through this fairly quickly just as a review for you guys. So what is a vector? And a vector is a quantity that has both magnitude and direction. It is a directed line of a segment or an arrow. So if you recall, we would write a vector with this one line and it would be AB. So this is vector starting at the initial point of A going in the direction of B. So here we have it starting at the initial point of A and going to B. So the name of this vector would be A initial point B with the line above it. And remember, vectors only have one arrow on the end. All right, then we talked about component form, and it lists the horizontal and then the vertical direction. So instead of it's similar to an ordered pair, but instead of it having a parentheses, it has those little bracket kind of looking things for component form. So what is the component form of CD? C is your initial point, so that's where you're starting. And remember, you have to do this in the direction of X first. So make sure you go this way first. So we're going over 2. And then we're going to go up 3 to end at D. So the component form would be 2, 3. All right, what is the component form of EF? So make sure you start at E. And a lot of times kids go 1, 2, 3, but that is down, which is your Y value, and that's the number that needs to go second. So make sure that you put down 3 as your second number. So remember, we have to do the X value first. So we go 1, 2, 3, 4. So the component form of this vector would be 4, -3. All right, then we talked about the magnitude. And the big thing you have to remember is that magnitude is the length of a vector. So a lot of times what we did is we turned this vector into a right triangle. So they would give you the component form of, let's just say, 3, 4, and then they would want to know what the length of this is. So in the direction of, I have my numbers kind of backwards here, but in the direction of Y, which would be this one, Y, and the horizontal distance, which is X, would be 3. So here's your right angle, and then they want to know the hypotenuse. So it would be basically setting up 3 squared plus 4 squared gives you AB squared. Remember, this is your basic 3, 4, 5 triangle. So AB is going to be 5. So the point is that we typically turn these into a right triangle, or you could have used the distance formula, whichever one you choose. All right, direction. The thing that we need to make and know about direction is that a vector, so this vector AB, when they ask you what the direction it means from a horizontal line and from the positive x-axis going back counterclockwise. So sometimes they give you this exact thing in nautical form, and so it's saying north bearing east 30 degrees, and so that would be your 30, and then this is still your 60 from your horizontal. So when they say direction, they're talking about that angle. When they say magnitude, they're talking about length. All right, so draw each vector. So this is going to be 1. So this is now your homework. So this is what you should be doing on a sheet of paper. All right, continuing on. We're not going to do our homework together here, but I have one more example to go through that's talking about vectors. So an airplane is flying at a constant speed of 400 miles per hour. At a bearing of north 70 degrees east, and there is a crosswind blowing that is due north. So how is this a wind affecting the speed of the plane? So what are the actual plane's speed and direction? And they're going to ask us to round to the nearest tenth and then the nearest degrees. So basically we have 2 vectors going here. One is that we have a vector and the airplane, so one is the airplane and one is the wind. So if this is the airplane, and then I have to have another vector. I'm going to add another vector to it, and it is going to be the wind. The wind is much easier because it is just a wind that is blowing straight north, and they tell us that this is 60 miles per hour. So now we have to go in here and find the plane. So the plane is flying at a vector, and they tell us that this is going 400, what was it, miles per hour. And they tell us that this degree right here, they're saying north 70 degrees east. So this is a 70-degree angle. Now we know that this is a right triangle in here. So if that's 70, we know this is 20. And they want us to actually find the speed and the direction. So with the speed and the direction, we actually need to find the distance. So if we need to find the distance of that, what we need to find out is what that vector is. So we need to find out our x and y values. So if I call this part of it right here x and this part up here y. So what can we do to solve for y? Well, we know this 20-degree angle and opposite, and we know the hypotenuse is 400. So we can set up the sine of 20, and the sine of 20 is going to be the side opposite, which is y, over your hypotenuse, 400. So we can go ahead and solve this. So we have 400 times the sine of 20 is y. So in my vector here, I am looking for what this y value is going to be. All right, so go ahead and do that on your calculator, and this y value should come out to be 136.8, if I did my math right there. All right, now we have to go in and find out what the x value is, so I can put the x value over here in this vector. So this vector over here, if I'm looking for x, that is your adjacent. So I'm going to do the cosine of 20, and the adjacent is x over my hypotenuse, which is still 400. So I'm going to take 400 times the cosine of 20 is going to give me x. So go ahead, grab your calculator, and if you take 400 times the cosine of 20, we get like 375.9. So this makes our vector. So now if we want to actually find, now I need to add to this vector. So to this vector, I need to add to it the wind. So this is the airplane vector. And now I need to add the wind to it. Well, wind, is that an x value or a y value? If it's going straight north, isn't that an up and down? So isn't that a y value? So it would be 60. So now what this is we have to take and get a resultant vector by adding these two together. So my resultant vector of adding these two vectors together, my x value is not going to change. So it's 375.9, but that y, I have to take that 136 plus 60, and now this is going to be 196. So this is the plane with the wind affecting it. Okay, now I might have to create myself a little bit more room, or actually I can just take this vector and I'm just going to go on to a next screen here and copy that resultant vector down. So we are dealing with the vector of 375.9, comma 196.8. This was our resultant vector. Now I need to find the distance of this. So remember, with this distance, like I showed you before, we're just going to use the Pythagorean theorem to find this. So I'm going to take 375.9 squared plus 196.8 squared, and then remember to take the square root of that, and that is going to give us what the actual plane speed is. So the airplane speed, when we do this resultant vector, is 424.3, and I think that label was miles per hour. Now remember, with this new resultant vector that we have with your x and your y values right here, So this x value was 375.9 and the y value was 196.8. This angle in here, or the direction, got affected by having that resultant vector. So we are trying to find what this resultant vector, what this direction is going to be. So if we're trying to find this right here, we have opposite and adjacent. And what ratio gives us that? So we're going to have the tangent of x is the side opposite 196.8 over adjacent, which is 375.9. Now, how many of you remember how to find the angle measure when we are given the correct ratio? So remember, this is when we have to use that inverse tangent button. So you're going to hit second tangent, and then the parentheses pop up for you. So just do 196.8 divided by 375.9 and go ahead and hit enter. And I think that gives you something like 27.6, and they asked us to round to the nearest degree. So we're going to say that this is in a direction of 28 degrees. Now remember, if you want to give it in nautical form, that they want to give us north and then coming back east. So what we would do would be 90 minus 28, and 90 minus 28 is going to give me 62. So we could write it at north 62 degrees east. So that means going north and then coming back 62 degrees east. So that this angle in here would be 62, leaving the remaining part of 28. So the two main questions here would be the speed of the plane is 424.3 miles per hour, and it is flying at a direction of 28 degrees.